Forging cybersecurity experts. Secure Ninja.
Hey everyone, I'm Alicia Webb with SecureNinjaTV. Now, our free preview of SecureNinja's online Sensei series has generated such a positive reaction that we've decided to give away every single module from the Cyber Kung Fu course, featuring Larry Greenblatt, Tom Updegrove, and me. If you like what you see and would like to experience a Secure Ninja training course in person at any of our training locations, we have some amazing time-sensitive specials for you. Just visit SecureNinja.com/specials for all of the do not miss deals. And now, here is your free module from Cyber Kung Fu for the Certified Ethical Hacker version 8. Enjoy.
All right, Module 10, Denial of Service. Now, we've already seen a lot of the fields, and all the fields actually, in the IP packet header, and talked about how I could, just when I introduced fragmentation, instruct you to build a packet larger than any packet should have been, right? So I give you a fragment, I say, all right, you're up to 65.534. There's another fragment coming, and it's 1,500 bytes long, right? Well, and that was the ping of death. You can never prevent all denial of service attacks. It's just one of those things. Once you allow a service, your telephone, you can't prevent people from calling you up to the point where you can't get another phone call. It's just one of those things. So we mentioned that there's two broad categories of attacks. There are active and passive. Now, passive attack like sniffing, I could have encrypted. I can't tell when they're sniffing, so passive attacks are undetectable, but they are preventable. I could have encrypted it. Denial of service or active attacks, I can certainly tell when someone's calling me on the phone, but I can't prevent them all. We can look for well-known ones, though. All right, so our objective, just understand the differences between a denial of service. So remember the SYN flood. I mentioned earlier in the scanning module, if I send you a SYN, you send me a SYNAC, I don't complete the three-way handshake, you'll hold that open for a little bit. All right? If I send you another SYN, now I'm going to spoof that source IP address. There's no reason to have your real address in any denial of service attack. Keep that in mind. That could be very important when you consider the test and the books as you read them and say, well, why am I spoofing it? Because there's just no real reason. It's like robbing a bank and leaving your business card. And if you need the money, I'm over here, right? So where do you live? I live at this phony address. So it's the signature of every denial of service attack. All right. But if I could get multiple components, machines working against you, now I have a distributed denial of service. All right. And we mentioned that I could do that by just pinging the broadcast address of a network, and any host that still responds to that will reply back to that. Let's take a look at the board and refresh our memory exactly how that worked. So I have a network./I've been given the address range of, say, I hate to use a real range, but 201.1.3.0/24. And hopefully I didn't just make these guys a target. But /24 means, well, I have 32 bits of addressing. And /24 tells me the first 24 bits are mine. Right? I have 8 bits for addresses. So I can have, well, 2 to the 8th, 256. I have a network address. I have a broadcast address. It's going to be important. So I have 254 possible machines in here, and I don't need to draw that many. I'll just draw a couple here. But I'll make this guy 201.1.3.5. And somebody on the outside pings 201.1.3.255. When I put 255 in that host field, I said everybody on that network. Now, I'm an old Cisco guy. Cisco guy, by default, always had no IP directed broadcast. No router would forward an all routes broadcast, but that's not an all routes broadcast. That's directed at this network. And some routers would allow that. I could enable it on my Cisco. Well, if it was enabled, everybody would get it. Now, the fact is, Microsoft does not reply to this, but anybody who follows the RFC would, and they would reply back, all Linux hosts or Mac, oh, you wanted to get back to you forever and ever with the largest packet we supply until you cry uncle? and this guy goes down. And because I had multiple machines involved, this wasn't just a denial of service, it was a distributed denial of service. We mentioned this a little earlier, but sometimes it's nice to hear it again. Why did I let anybody in whose source address is from my network? So one great countermeasure to prevent yourself being a victim. Don't let anybody in your network whose source address is already from your network. Right? Because I may have left that out. By the way, they're going to spoof the source to equal the victim. Right? So everybody gets it, hits that victim. Some people have decided to just filter out ICMP, but this Smurf attack can be done with UDP, and that's known as Fraggle. Historically been a question on this test, by the way. They always update it. I don't ask people to memorize answers. I ask you to understand concepts. All right. Another thing that I might want to do, though, is make sure I don't support the directed broadcast feature. And you can find it real easy with the Smurf amplifier registry. And I know we took a look at that in the scanning module. All right. Now, though, so many denial of service attacks, though, are with botnets. It's so bad. And I tend to think that it's kind of like, well, at first when viruses came out, every time I went to troubleshoot a problem, people said, do you think it's a virus? I don't think it's a virus. Now I just assume that it's like my body. I have dozens or more viruses. I just hope most of them just don't do anything bad. In fact, some of them might do good stuff. I don't know, like yogurt, you know. Anytime I take an antibiotic, Tom would always, you know, if I like I had strep throat one year, and I had to take an antibiotic, as soon as I was done, Tom goes, now you eat some yogurt, Larry, because you need to have bacteria, you know, it's good bacteria. Oh, okay, all right. So I don't know what's going on. You know, I remember the first, to me, botnet would have been the SETI program. So it was a big thing. It was around the early 90s is where I became aware. It's like, you know, you could help participate. You know, your CPU is not always busy. You could donate some free CPU cycles to the SETI program, and well, that times it just blew up, right? So that's all botnet really is. Just parallel processing and all machines, you know, involved in it, and it's just amazing what they're doing with it. And I was looking just this morning at how many botnets are already there on Android. Oh, gosh, and BlackBerry. All right, so we already looked at the IP header, and people just lie about some of the information here and can create a denial of service. So I said earlier in the scanning field, so the scanning module, please refer back, but I manipulate these fields, the total length, ID, flags, and fragment offset, and I could create a fragment that's larger than any fragment should be, and again, that should be, or a packet should be, and that's the ping of death. I could have you just say the same fragment offset. So this box goes here, and this box goes in the same exact memory address space, and that was teardrop, later new tier, boink, or bonk, whatever. Most of these have been patched, but that Smurf attack still works, guys. That still works. Another one we mentioned here is if I sent you a packet, and actually the classic way to do this was use a UDP port 7 echo request, source port 7, destination IP, same as the source. So you get it, you just keep chasing your tail, right? Again, you patch your system to say don't do that. Keep in mind, as we move into the web the domain later, there's only 20 fields in this IP header. It's hard to get it exactly right, but it is only 20 fields. How many lines of code in just the kernel of Microsoft Windows or Linux? I remember when Windows 2000 came out, they bragged like it was a big thing, and they said, we've got 50 million lines of code in the kernel. We're like, no, that's not good. Oh, 35 million lines of code. They counted, but still, consider Six Sigma. Six Sigma tells me that for every million somethings, the best quality I'm likely to get, I really try hard, would be 5 nines, or for every million somethings, I'd have 3.94 defects. If there's 50 million lines of code, you're never going to get it right. When people tell me, when are they going to finally build this stuff right? I go, well, we've been dealing with fire since prehistory. When are people going to stop burning themselves? We'll fix the internet sometime after that. All right, so some common attacks. You're definitely going to see the SYN flood, and there's a couple of defenses. I mean, I could just wait a shorter time. Not me. I'd have the stack tweaked that way. I could guarantee a delivery. I'd just say, hey, let me hang up and call you back. And they have SYN cookies or reset cookies, right? Smurf and Fraggle, these are distributed denial of service attacks. Now, buffer overflows we're going to cover more in our apps domain, which I combine web apps, buffer overflows, and SQL injection into one domain, because it's all application layer attacks. Now, there's a lot of places where you have input buffers. But when you think of an application and it asks you to put something in and enter your name, I don't care if you're from the former Yugoslav, is probably not over 50 characters. Now, the first time I saw a buffer overflow was an accident. It was very classic on an IBM PC or an XT. If you leaned on that keyboard too long, you would input the keyboard buffer, too many keystrokes, and it would start beeping. And the only way to get rid of that was to turn your machine off. What happens is, do a quick look, and then again, much more detail in application. When you check into the hotel and they give you a room, or you load up an application from a hard disk, the operating system, somebody at the front, the clerk at the front desk, actually I like the BOSs to be blue. Somebody at the OS, one of the security kernel mechanisms says, it's actually known as the memory mapper. You want to log into this hotel? Here's your memory address space. Right. Now, I have an area of memory that I can't change. That's like file, open, blah, 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 blah. It's known as text. And this is like in my hotel room. I can't move the toilet seat the toilet or the sink around. There's nothing I'm moving there. But then it has to load in other modules. Now, there's chairs in here. I might call them up and say, can we have an extra bed or something? And they could bring stuff in there that's authenticated by the hotel. And that goes to the heap. And that's like Microsoft and Word could load in spell checker or a thesaurus. Now, the program needs to know where to go back. And this is where it gets tricky. At the end of this, it says, go back here to run, and that's your instruction pointer. Actually, EC Council's semantics of business vocabulary, we'll call this an execute instruction pointer. Some people like to save keystrokes and just call it an IP. We want to pass our test. All right, now, I could bring my bags in from into the hotel from I bring my kids. And if I leaned on that keyboard too long, for instance, I filled up and I overwrote the EIP and it didn't know where to go. So that's why buffer overflows originally resulted in denial of service, because we no longer had a place to point back. When we get to applications, we're going to see how people were able to go, how about if I just put a code there and actually tell the instruction pointer, run my code. But we'll worry about that in a later domain. All right, so we mentioned again, ping of death is when and again, this would have to be the 90s to work. I still question why every security test still wants me to know this. We call them DYT, dead yet testable attacks. So if it were 1998, you would be able to use fragmentation to instruct a machine to build a packet larger than, and it should be 65.535 if you start with 0, 65.536, but anything larger than that shouldn't work. And that used to, again, overflow a buffer, really, and create a denial of service attack. Teardrop, the overlap of fragments, but today it's with these botnets. WikiLeaks had some support from Anonymous and a lot of hackers, and they took down, did a massive denial of service attack against MasterCard, Visa, PayPal, and a number of sites, and they used this tool right here. So, I always say, just don't think that you're the toughest guy in the neighborhood. My buddies, my band members are also from my neighborhood. Now, unlike me, they didn't study martial arts all their life. They ain't afraid of me. Greenie, I got a black belt in tire iron, and you ain't got eyes in the back of your head. So just don't start trouble. And we looked at this earlier, but just to consider it again, this is how botnets can work today, right? You think you can really stop a distributed denial of service attack if I've got, again, the largest one I've heard of now is 30 million infected machines. You're not going to be able to stop it. So that's why I say in your rules of engagement, I don't know anybody who wants to test for distributed denial of service vulnerabilities, because the answer is it's going to work. All right, Alicia, any questions?
You're saying you really can't prevent all DOS attacks. That sounds scary.
Unfortunately, it's something you have to live with. But yeah, I mean, you can look for well-known ones, and especially if it's like a one-to-one, but a distributed denial of service attack, Anytime you have a service, there's just no way to guarantee it's up. In fact, actually, I invented one by accident. So we can look at my screen here. I told you I kind of like to sniff around. I'm so glad Google won their case. But whatever the case is, so sitting in the hotel room, I noticed I was getting spanning tree updates. Now, it's a little high level, but let me kind of explain this. It might help students anyway. If I have a bridging loop, meaning if we recall back from our sniffing modules, and maybe I was smart, I wanted to architect a solution with redundancy. I was worried about, there might be a break in the wire or something, and so now I've got 4 bridges here, right? And remember, a bridge's job is to read the layer 2 frame header and make a forwarding decision based on the MAC address. All right, so now, when it sees an incoming packet, if it knows the destination MAC, it'll forward it. But if it's an ARP, it's a broadcast, the bridge is going to forward it everywhere. So send it out here and send it out here. This receives it here. He's going to send it out here, but he's going to send it out here. And now he receives it here. He sent it out here, and he just got it from here. He sent it. They're just going to keep forwarding this, and this one ARP is going to take down the entire network. So network designers, I believe, has developed a digital equipment. It's originally called the bridge-to-bridge protocol. Now we call it spanning tree. Spanning tree will elect somebody to be the root. And everybody will learn, all the bridges will say, what's my best path to the root? So assuming these are all, say, the same speed link, 100 megabits. Well, this would be my best path. I will listen here, but I won't send anything. This is a separate path, doesn't go anywhere to a redundant. Assuming that these are all same speed links, and let's just, for argument's sake, give him another connection here. Well, this is my fastest path. This is my fastest path. So now I have a network that spans the entire network, but like a tree, no circular branches. So if the problem is a broadcast storm, the solution is spanning tree. And this sounds great, and it is a great thing. Problem is, the access controls in a spanning tree, I discovered, are not always either implemented or implemented well. And so I'm at a hotel. Now, keep in mind, spanning tree is very dynamic. So if this bridge goes down, everybody has to relearn, what's the best path now? And that, by default, takes 50 seconds. So everybody's going to be shut down for 50 seconds as spanning tree runs. And the reason you know everything's okay is because the root bridge, every 2 seconds, says everything's fine, everything's fine. This should not come to my hotel room, though. If it's configured properly, since there's no bridge that'd be in my room, I shouldn't see it, but I saw one. So here's a spanning tree, and I loaded up with this tool, and this is a packet editor. And I edit the packet, and I go to the spanning tree protocol, and the BPDU is the bridge protocol data unit saying there has not been a change. So everything's fine. And I go into hex, and I go, really? Yeah, there is. And I changed it. And then I said, I wonder what would happen if I sent one. But I don't do that type of stuff. But I did go to my class, and this is in 2001, and I said, gosh, I wonder what would happen if I sent it. So then I go at lunchtime, I go to read my mail, and I can't get any mail. So Larry starts sniffing the network, and all I see are BPDUs going off. And I was like, and recalcs, and I was like, well, that should only take it down for 50 seconds, but this was the entire. So I come back to class, and I go, did anybody launch that attack? No hands go up. But this particular hotel has an O'Malley's in it. And O'Malley's has Guinness on tap. So later on, I'm there, and a guy comes, I go, dude, I'm sorry, that was me. You did what? And he goes, I can't believe how easy that was. He knocked down the entire hotel. The entire hotel was down for lunch, and I said, dude, it should only have lasted 50 seconds. And he goes, I just kept clicking send. And people were encouraging me, Larry, you should write a tool, you get known. I was like, I don't want to be known as the guy who broke stuff. I come from a network ops background. I want to be known as the guy who kept it running or made it run faster now, and you like me. But it's that easy. Anytime there's a service, you can deny it. It's that rough.
Would a DOS ever be applicable in a real pen test?
Yes, and I hope I didn't say that wrong. So I caution against distributed denial of service attacks in a pen test. Probably not a good idea. But suppose in the pen tester I use it to set up something else. So maybe I didn't want to get caught by your IDSs and I DOS the sensors. That would be noticeable, but it could be some way to obfuscate the attack. Or you're going to use your logging servers to prove that I broke in there, but I DOS, say, the time servers to those logging servers. Now those logging servers can't be trusted. So they go to court. How come these times don't match? So yes, and I thank you for asking that question. So as I pointed out, distributed denial service, probably not something you want to do in a pen test. Denial service absolutely could be applicable. Great question.
No, why exactly would anyone ever execute a DOS attack?
You know, it's kind of like, to me, that's why I always think it was lamer. It's kind of like, well, if I can't play, then nobody can play. I'm turning the lights out and no one will have it. So, you know, it's, in many ways, it's lame. But if it's to set up another attack, so I think of it, you know, maybe someone's going to light a fire in a building, and I hate that, I don't want to think I would do that, but maybe I first DOS the smoke detectors. So then when the fire goes off, right, so I could see where it could be useful, but it really depends on your work. I'm mostly a network operator guy and from the private sector. My job was keeping traders trading. I don't want to DOS them. I guess I could have DOSed our competitors, but I don't think that's very cool. I wouldn't want anybody to do that to me. So you know the golden rule, right?
Absolutely. Be cool. Stay
Be
ethical.
cool, and that means don't do
others.
anything to others you wouldn't want done to you. Yeah.
Exactly.
Awesome.
Cool. Thanks, Larry.
You're welcome. Thank you. And that completes this module.
Now we hope you've enjoyed this free module, but there's lots more. The Cyber Kung Fu course has 29 videos in all and will really help build you a solid understanding of the CEH version 8 curriculum. Don't forget, if you prefer to attend one of Secure Ninja's courses in person at any of our training locations, you really need to visit SecureNinja.com/specials for some amazing discounts and other deals. I'm Alicia Webb. Happy training.
Secure Ninja TV is brought to you by SecureNinja.com, a world leader in cybersecurity training and certification. Our master instructors will help build you into a highly skilled and marketable security professional. Secure Ninja, forging cybersecurity experts.